Find the indicated limit if it exists. The limit of square root of x squared minus 4, and then minus 3x being outside of the radical as x approaches infinity. If we try to use substitution with a very large number squared, minus 4, and taking the square root of that, we're going to get an infinity value minus 3 times a very high number will be infinity. And we can't evaluate infinity minus infinity. It's not equal to 0. So in order to find this limit, we have to begin by multiplying this function by the conjugate of itself. So we're going to put this over 1, and we're going to multiply by the square root of x squared minus 4 plus 3x outside of the radical in both the numerator and denominator. And when we do that, we will get x squared minus 4 outside of the radical, and then minus 9x squared. Remember, when you have a difference of squares, the middle terms will cancel each other out. And then in the denominator, we will now have the square root of x squared minus 4, and then plus 3x. We're going to take the limit of this as x approaches infinity. All right, we see some terms that are like in the numerator, so we can combine these together. We're going to have negative 8x squared plus 4 over the square root of x squared minus 4 plus 3x. And we're going to take the limit of this as x approaches infinity. Now, if we look at the degrees that we have remaining in our numerator and denominator, we see that the degree is higher in the numerator, so the limit will be positive or negative infinity. In order to determine which it is, positive or negative, let's actually think about what will happen if we substitute a very high number in for the x values. So we are going to have a very high number, let's say 10,000, if we square it, really huge number, times negative 8, that'll make the numerator become a negative number. And then in the denominator, if we put that 10,000 in here, square it, subtract 4, and then square root it, it'll be a very high positive number, and we're going to add another positive number to that. So we are going to have a negative number over a positive number, and a negative divided by a positive is negative. So therefore, we have negative infinity. And we can verify this using the graph. So here's the graph of our function, and as x approaches positive infinity here, you can see that our function does indeed get smaller and smaller, or approaches negative infinity. And then if we also put in our revised function that's equivalent to it, we can see that it directly overlaps it. So again, this verifies the answer that we have here of negative infinity, or answer choice B.